We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system. Now, astronomers have captured that moment live, streaming in real time around the globe of them watching all of this. Take a look at this.
Yes, look at that bad boy.
This is a raw image, so this is not even like, I mean, this is just directly from the telescope right now.
You're looking at a piece of what would have become a planet in another star system. This is a building block from somebody else's home.
Imagine a cosmic object, older than our sun, tearing through our solar system at 130,000 miles per hour, defying everything we know about physics. Discovered just days ago, 3I Atlas isn't just another comet. It's an enigma that's shattering our understanding of space. Its dust streams toward the sun, its chemistry is eerily absent, and its path is so precise it seems almost impossible. Is it a cosmic anomaly, or is there something more sinister at play? Buckle up, because the truth behind 3I Atlas could change everything we think we know about the universe.
Because it's the third time we've ever seen an interstellar object. And interstellar doesn't just mean Matthew McConaughey, it means something not from our solar system. It's interstellar, it's between suns. And so this thing came from like beyond our solar system and is just passing through. It's only the third time we've ever seen something like that.
Is that why it's called 3I?
Yeah, because it's 3I, not 1I or 2I, it's 3I. That's exactly right. So it's exciting for that reason alone. And if it turns out to be a spacecraft, sure, I'll buy them lunch.
Discovered on July 1st, 2025, by NASA's Atlas survey, 3I Atlas is more than just a visitor passing through our solar system. It's a cosmic anomaly that's challenging the very foundation of what we know about comets and interstellar space. Unlike the typical comets we've studied for centuries, this interstellar object is doing things that simply don't make sense based on what we've observed in the past.
And a mysterious visitor is on its way to Earth, moving closer. 137,000 miles per hour. Is it an alien ship, a comet? Scientists and researchers are left puzzled. To unpack the mystery behind 3I Atlas,
more data should be collected to uncover the nature of this object.
3I Atlas is a mystery that has drawn the attention of astronomers and physicists worldwide. It's different from anything we've seen before. When the object was first discovered, astronomers thought it was just another routine comet, something similar to the other icy bodies that orbit the sun. However, when scientists started to track its trajectory, they realized something unusual. Unlike other comets, 3I Atlas wasn't orbiting the sun in the same way. Instead, its path was hyperbolic, an open, steep curve that could only mean one thing. It wasn't part of our solar system. This object had come from deep interstellar space, far beyond the reaches of our sun. The moment astronomers realized this, the excitement within the scientific community was palpable. 3I Atlas was no ordinary visitor. It was the third confirmed interstellar object to pass through our solar system. The first, Oumuamua, was spotted in 2017, and the second, 2I Borisov, was discovered in 2019. But the 3I Atlas was much more significant than either of its predecessors. It was bigger, potentially up to 7 miles in diameter, making it far larger than Oumuamua, which was just 200 meters across, and 2I Borisov, which was roughly 1 kilometer wide. The object wasn't just big, it was active too. As is typical for comets, it displayed a glowing coma, a cloud of gas and dust that forms around the comet as it gets closer to the sun. This glowing cloud is the result of solar heat causing the comet's icy material to sublimate, turning solid ice into gas. It's a predictable process that happens to nearly every comet, and it's what gives comets their characteristic bright tails. However, when scientists started to study 3I Atlas more closely, they noticed something completely unexpected. The behavior of this comet didn't fit the usual pattern. When comets come close to the sun, solar radiation pushes the dust and gas in their coma away from the sun, creating the familiar tail that always points in the opposite direction of the solar wind. But with 3I Atlas, this wasn't happening. Instead of the typical dust tail stretching away from the sun, this comet was showing a strange dust stream that was actually directed towards the sun. This is like seeing a kite flying into the wind, instead of being carried away by it. It defies the basic laws of physics we've known for centuries. This sunward dust stream is just one of the many peculiarities surrounding 3I Atlas. The object's behavior had scientists scratching their heads, trying to come up with explanations. One of the first questions to arise was why this comet wasn't displaying the usual chemical activity we expect from a comet. When astronomers observe comets, they usually look for certain chemical signatures in the light emitted by the object. These signatures help identify the composition of the comet, such as the presence of gases like cyanogen or diatomic carbon, which are typically abundant in the volatile gases released by the comet as it gets closer to the Sun. But when the team at NASA's Hubble Space Telescope took a closer look at 3I Atlas, they found something unusual. The object didn't seem to be emitting any of these chemical signatures. It was like a fire burning without any smoke. Early spectroscopic scans of 3I Atlas were eerily blank, showing little to no chemical activity. The object seemed to be hiding its secrets from us. It wasn't until later, as it neared the Sun, that astronomers detected a faint trace of cyanogen, but it appeared much later than expected, as if the comet was reluctant to give up its secrets. The strange behavior of 3I Atlas was raising more questions than answers. Was there something about its surface that was preventing it from displaying the usual cometary behavior? One theory suggested that the object's surface might be crusted over, hardened by billions of years of exposure to cosmic radiation as it traveled through interstellar space. If that were the case, it might take longer for the comet's ices to sublimate and produce the usual outgassing. But this didn't explain the sunward direction of the dust plume. Another theory was that 3I Atlas might have a misaligned spin axis. This could mean that only certain parts of the comet's surface were being exposed to the Sun at any given time, causing uneven outgassing. But even that theory didn't fully explain the unusual behavior. Adding to the mystery, the James Webb Space Telescope detected something else on August 6, 2025. The JWST found a cloud of carbon dioxide surrounding the 3I Atlas stretching 348,000 kilometers across. The mass loss rate of the comet was 70 kilograms per second, but there was almost no water vapor detected. This was unusual, as most comets are water-rich. But the 3I Atlas seemed to be emitting mostly carbon dioxide. Some researchers speculated that the object might have originated in a region of its parent star system that was rich in carbon dioxide aces. If this is the case, it could mean that 3I Atlas was born in a very different kind of star system, one far removed from the conditions of our own solar system. This new insight, along with the strange behavior already observed, suggested that 3I Atlas was not just another comet. It might be a relic from a star system unlike our own, possibly formed in a region where temperatures were low enough to allow carbon dioxide to freeze, creating a comet that behaves very differently from the ones we're used to seeing in our solar system. The object's size, composition, and unusual behavior continue to captivate scientists. With new data coming in from various telescopes, the mystery of 3I Atlas is far from being solved. Each new observation gives us a little more insight into this strange cosmic wanderer, but it also raises even more questions about the true nature of this object and the star system it came from. As we continue to study the 3I Atlas, we're confronted with a fundamental question: what is this object trying to tell us about the universe? Could it be a glimpse into a star system so different from our own that we can't even fully comprehend its characteristics? Or is it merely a cosmic oddity, a one-time anomaly that will never be seen again? One thing is certain: the more we learn about 3I Atlas, the more it challenges our understanding of the cosmos. Its strange path, sunward dust, and unusual chemistry are pushing the boundaries of what we thought we knew about comets and interstellar objects. And as we continue to explore the universe, the mystery of 3I Atlas serves as a reminder that there's still so much out there that we don't understand. And that's what makes studying the cosmos so endlessly fascinating. When 3I Atlas was first detected on July 1, 2025, It appeared to be just another typical celestial object making its way through our solar system. But as scientists began to examine the data, they quickly realized that this interstellar visitor was anything but ordinary. 3I Atlas has captivated the attention of astronomers across the globe, sparking debates, theories, and even questions about the very nature of the universe itself. What makes this object so peculiar is not just its size or its origin, but its bizarre behavior that's making scientists reconsider long-standing theories about comets and the laws of physics. It was discovered by NASA's Atlas survey, which was originally designed to track near-Earth objects, such as asteroids and comets. However, this discovery was something entirely different. When the object was first spotted, it seemed to be an ordinary comet making its way toward the Sun, but its path quickly indicated something far more mysterious. The trajectory of 3I Atlas was not that of a typical comet. Rather than following a circular orbit around the Sun, the object followed a hyperbolic path. This means that 3I Atlas was not bound by the Sun's gravity in the same way that most objects in our solar system are. Its orbit indicated that it had come from interstellar space, and it would eventually continue on its journey out of our solar system after passing through. This hyperbolic path is a strong indicator that 3I Atlas is the third confirmed interstellar object to pass through our solar system, following the discovery of Oumuamua in 2017 and 2I Borisov in 2019. What sets 3I Atlas apart from its predecessors is not just its interstellar origin, but its size and activity. The object is estimated to be about 7 miles in diameter, which makes it the largest interstellar object ever observed. By comparison, Oumuamua was only about 200 meters long, and 2I Borisov was approximately 1 kilometer in size. So not only is 3I Atlas massive compared to these other interstellar visitors, it is also showing signs of activity that have never been seen in previous interstellar objects. Comets are known to be icy bodies that form in the colder regions of a star system, composed primarily of ice, dust, and rock. As a comet approaches the Sun, the heat causes the ice to sublimate, turning solid ice into gas and releasing dust. This process creates a bright coma, or cloud, of gas and dust around the comet. And as solar radiation pushes the particles away from the comet, it forms a tail that always points away from the Sun. This is the typical behavior of a comet, one that has been observed countless times over the years. But 3I Atlas wasn't behaving like a normal comet. As astronomers observed it more closely, they were taken aback by the object's unusual behavior. On July 21, 2025, NASA's Hubble Space Telescope captured an image of 3I Atlas, revealing something unexpected. Instead of the typical dust tail pointing away from the Sun, 3I Atlas had a dust plume that was directed towards the Sun. This was baffling, because solar radiation should push dust particles away from the comet, not towards it. In fact, the object's dust cloud was behaving like a kite flying into the wind rather than with it. This observation is in direct contradiction to the expected behavior of a comet, and it left scientists scrambling for an explanation. Why was the dust stream of 3I Atlas behaving in this way? One potential explanation that scientists proposed is that 3I Atlas might have a surface crust that has been hardened by billions of years of exposure to cosmic radiation. If this were the case, it could be preventing the usual outgassing process, delaying the sublimation of the comet's ices until it gets closer to the Sun. This might explain why the dust plume was heading toward the Sun, rather than away from it. However, this theory doesn't fully explain. Another theory suggests that the spin axis of 3I Atlas might be misaligned, meaning that only certain parts of the comet's surface are exposed to the Sun at any given time. This could cause uneven outgassing, which might explain the strange sunward dust tail. However, this theory doesn't account for the delayed chemistry or the complete lack of chemical activity in the early observations. As if these strange observations weren't enough, the James Webb Space Telescope (JWST) added another layer of complexity when it detected a cloud of carbon dioxide surrounding the 3I Atlas. This cloud stretched an incredible 348,000 kilometers across the comet, and the mass loss rate of the object was 70 kilograms per second. Surprisingly, water vapor was nearly absent, with only a small amount detected. This is highly unusual because most comets are rich in water, but 3I Atlas seemed to favor carbon dioxide. This finding suggests that 3I Atlas might have originated in a region of its parent star system where carbon dioxide gases were more prevalent, possibly in the carbon dioxide ice line. This would mean that the conditions in its home star system were vastly different from those in our own, offering a glimpse into a completely unfamiliar environment. In addition to its unusual composition, 3I Atlas's massive size and strange behavior led astronomers to ask another question: why is this object so big? The Vera C. Rubin Observatory, which has been tracking the object, initially estimated that 3I Atlas's nucleus was about 7 miles wide. This made it the largest interstellar object ever observed, dwarfing the size of both Oumuamua and 2I Borisov. The odds of detecting such a massive object from interstellar space are incredibly small. In fact, some models suggest the chances are less than 1 in a million. Yet there it was, captured by the Atlas Survey, a system designed to track near-Earth asteroids, not interstellar visitors. This anomaly in size raises another intriguing question: is 3I Atlas a fluke, or could there be more objects like it out there in interstellar space that we haven't yet detected? The Vera C. Rubin Observatory is set to begin a decade-long survey of space and time, and it could potentially identify up to 50 more interstellar objects in the next 10 years. But for now, 3I Atlas stands alone as a statistical outlier, an object so large and so unusual that it's challenging our understanding of interstellar objects. Speaking of its trajectory, 3I Atlas's path through the solar system is nothing short of extraordinary. Its path is threading a cosmic needle, passing within 29 million kilometers of Mars on October 3, 2025, and then coming within 1.4 astronomical units of the Sun. After that, it will pass within 0.65 astronomical units of Venus. These incredibly close encounters with multiple planets within a short time frame make its trajectory almost impossible. Monte Carlo simulations, which use billions of random trajectories to model the chances of such an event, show that the odds of 3I Atlas passing so close to these planets are less than 0.01%, or about 1 in 20,000. To put that into perspective, imagine throwing a dart at a spinning globe and hitting 3 specific cities in a row. That's the level of precision we're talking about here. Its path also aligns closely with the ecliptic plane, the plane where most of the planets in our solar system orbit. The chances of this happening with a random object are around 1 in 500, which only adds to the mystery of 3I Atlas. This improbable trajectory has led some astronomers to question whether this object's path is truly random, or if it's somehow being guided or influenced by something else. Some researchers, such as Adam Hibbert and Abraham Loeb, have proposed a controversial theory. They suggest that 3I Atlas might not be a comet at all. Instead, they believe that its precise planetary flybys and the low probability of such alignments might indicate that 3I Atlas is a technological object, possibly a probe. They point to its unusual alignment with the ecliptic and its potential to use a reverse solar over the maneuver at perihelion, a technique that spacecraft use to gain speed by using a star's gravity. While most scientists dismiss this idea as speculative, it has gained some traction due to the object's strange behavior and trajectory. For now, though, the consensus remains that 3I Atlas is a comet, albeit an extraordinarily strange one. Its peculiarities are forcing scientists to rethink what we know about the behavior of comets and interstellar objects. As more data comes in from a variety of sources, we're beginning to understand just how complex and diverse these objects can be. The more we study the 3I Atlas, the more questions arise, and the more we realize that our understanding of the universe is still incomplete. As astronomers continue to examine 3I Atlas, its size, trajectory, and behavior only became more perplexing. The object's mass, estimated to be as large as 7 miles in diameter, makes it the largest interstellar object ever detected. By comparison, the first interstellar object, Oumuamua, was about 200 meters in length, and the second, 2I Borisov, was approximately 1 kilometer wide. The sheer size of the 3I Atlas alone is enough to make it a unique object of study. But when you factor in its strange behavior, it becomes something entirely different. One of the most striking features of 3I Atlas is its trajectory. Its path through the solar system is almost impossible, defying the odds in ways that scientists struggle to explain. On October 3, 2025, it will pass within 29 million kilometers of Mars, close enough for NASA's Mars Reconnaissance Orbiter to potentially capture high-resolution images of it. But that's just the beginning. After its encounter with Mars, 3I Atlas will come within 1.4 astronomical units of the Sun, just inside the orbit of Mars. A few weeks later, on November 3, it will pass within 0.65 astronomical units of Venus, making this an extraordinary sequence of planetary flybys. Monte Carlo simulations, which run billions of random simulations to model potential trajectories, show that the Atlas passing this closely to Mars, Venus, and Jupiter, are less than 0.01%, or 1 in 20,000. To put this into perspective, imagine being blindfolded and throwing a dart at a spinning globe, then hitting 3 specific cities in a row. That's the level of precision we're talking about here. The fact that 3I Atlas is threading a needle through the solar system, passing so close to these planets, raises a fundamental question. Is its path truly random, or is there something else going on? Some astronomers, like Adam Hibbert and Abraham Loeb, have speculated that the trajectory of 3I Atlas may not be. In a controversial preprint, they suggested that the object could be a technological probe, potentially sent to our solar system by an intelligent civilization. Their theory is based on the precise alignments of its flybys with Mars, Venus, and the Sun. According to their model, the alignment of 3I Atlas's path with the ecliptic plane and its close passes with the planets may indicate that it's not just a comet, but a deliberately guided object, potentially using a reverse solar over the maneuver to gain speed. As it passes near the Sun, the reverse solar orbit maneuver is a technique used by spacecraft to gain speed by using the gravity of a star. The idea is that the spacecraft swings by the star, using the star's gravity to slingshot it toward its destination. If 3I Atlas were a probe, its precise alignment with the planets and its path could suggest it's following a similar trajectory. While most scientists dismiss this theory as speculative, it has generated a great deal of interest, especially because of the object's improbable path and behavior. Despite this, the consensus within the scientific community remains that 3I Atlas is likely a comet. However, even if it is a comet, its behavior doesn't fit the traditional patterns we've seen with other comets. For example, 3I Atlas has displayed unusual acceleration. Researchers studying its movement have found a small but consistent deviation from what gravity alone would predict. This deviation, estimated to be around 10 to the power of 7 meters per second squared, is too large to be explained by the usual outgassing effect we see in comets. In typical comets, the acceleration comes from jets of vaporized ice that act like thrusters, pushing the comet in a specific direction. But 3I Atlas showed this deviation before any clear signs of outgassing appeared, and even when the typical chemical markers were absent or delayed. One possible explanation is that the nucleus of 3I Atlas is composed of a thin reflective material, which could act like a natural solar sail. This would mean that the object is being pushed by solar radiation in a way that we haven't observed in other comets. Another theory suggests that exotic ices, such as nitrogen or carbon monoxide, could be vaporizing unpredictably, causing the object to accelerate in a way that we're not used to seeing in comets. However, no model fully explains the unusual acceleration yet, and this too is contributing to the growing mystery surrounding 3. Further complicating the situation is the object's unusual brightness. The Atlas survey data revealed something extraordinary about the object's light curve. The pattern of brightness changes over time. Researchers used quantum AI tools to sift through the data, and they detected a repeating pattern, almost like a cosmic heartbeat. The periodicity in 3I Atlas's brightness is so consistent that it exceeds 99.99% statistical confidence. This is especially odd because comets this size typically rotate every few hours or days, and their brightness usually changes as they rotate or as outgassing bursts occur. But the periodicity Atlas's brightness doesn't align with either of these typical explanations. The light curve of 3I Atlas is something new. While traditional comet science links brightness changes to rotation or outgassing, this object doesn't follow those rules. Some researchers speculate that the periodicity could be caused by a structural feature on the surface of the object, such as a reflective patch, which could cause changes in brightness as the object rotates. However, the precision of the periodicity suggests that there is something more going on. And this has led scientists to look at new ways of interpreting the data. Despite all these anomalies, the most puzzling feature of 3I Atlas remains its chemical composition. When astronomers first observed the comet using the Hubble Space Telescope, they found almost no chemical activity. Comets are typically filled with volatile gases, such as cyanogen and diatomic carbon, which emit light at specific wavelengths and reveal the composition of the object. But 3I Atlas showed almost no signs of these gases in the early scans. It wasn't until the object got closer to the Sun that a faint trace of cyanogen appeared, but it came much later than expected, as if the comet was hiding its secrets. This delayed chemistry, combined with the sunward dust tail and the unusual acceleration, continues to fuel theories that something is very different about this interstellar object. When the James Webb Space Telescope, JWST, turned its infrared spectrograph on 3I Atlas, it detected something surprising: a cloud of carbon dioxide surrounding the object. The cloud stretched over 348,000 kilometers and had a mass loss rate of 70 kilograms per second. What's even more curious is that water vapor, which is typically abundant in comets, was nearly absent. This suggests that 3I Atlas may have formed in a region of its parent star system that was rich in carbon dioxide ice, possibly located at the carbon dioxide ice line, where temperatures would allow carbon dioxide to freeze. This finding further complicates the picture of 3I Atlas and suggests that it could be a relic from a very different kind of star system, one that might have conditions vastly different from our own. Given all the unusual features of 3I Atlas, scientists are left grappling with the question: what exactly is this object? Is it just a very strange comet, or is it something more? Its size, trajectory, and behavior push the limits of what we understand about comets and interstellar objects. Whether it's a natural object or something else entirely, 3I Atlas is forcing us to reconsider everything we thought we knew about the universe. As scientists continue to observe 3I Atlas, they're faced with an even bigger question: what does this object tell us about the universe? Its composition and behavior suggest that it formed in a star system unlike our own, possibly in a region rich in carbon dioxide ices. The object's age, estimated to be between 7 and 11 billion years old, means that it has witnessed the evolution of the Milky Way's thick disk, a region of ancient stars far older than our 4.6 billion-year-old sun. Studying 3I Atlas is like opening a time capsule from a star system that is vastly different from ours, offering a glimpse into a cosmic history that we can't fully comprehend. Each new observation of 3I Atlas adds a piece to the puzzle. The data gathered by the Hubble Space Telescope, JWST, and other instruments reveal more about the object's unusual features, but they also raise more questions. As 3I Atlas approaches its closest point to the Sun in late 2025, astronomers are scrambling to collect as much data as possible before the object moves on to the next chapter of its journey. Its encounter with the solar system is brief, but the questions it raises will likely linger for years to come. As we reach the final part of our journey into the mysteries of 3I Atlas, it's clear that this interstellar object is much more than just an unusual comet. It has become a puzzle that challenges our understanding of celestial bodies, physics, and even the potential for extraterrestrial life. With each new piece of data, the scientific community is forced to grapple with questions that extend beyond the boundaries of conventional comet science. From its sunward dust plume to its odd acceleration, 3I Atlas is a cosmic enigma that continues to captivate the imagination of astronomers and the public alike. One of the most debated questions about 3I Atlas is whether or not it could be something other than a natural comet. The idea that 3I Atlas might be an artificial object, such as a probe, has gained some traction in recent months. This theory has been proposed by a small group of scientists, including Adam Hibbert and Abraham Loeb, who argue that the object's trajectory and peculiar features suggest that it could be a technological device. Specifically, they suggest that its precise alignment with the planets and its path through the solar system might not be entirely random. They propose that 3I Atlas could have been deliberately directed to pass through our solar system, potentially as part of a mission sent by an intelligent civilization. The idea of 3I Atlas being a probe is based on several unusual characteristics. For one, the object's trajectory is strikingly precise. It will pass very close to Mars, the Sun, and Venus in rapid succession, a sequence of events that is extraordinarily unlikely. Monte Carlo simulations, which model random trajectories, show that the odds of an interstellar object passing close to these planets are less than 0.01%, or 1 in 20,000. That's a level of precision that seems too improbable to be random. Additionally, the alignment of 3I Atlas with the ecliptic, the plane in which most of the solar system's planets orbit, adds to the mystery. This precise alignment has led some researchers to speculate that the object could be deliberately aimed, using gravitational assists or other techniques to guide it through the solar system. Despite the growing interest in this theory, the mainstream scientific consensus is that 3I Atlas is most likely a comet. Although the idea of an interstellar probe is fascinating, there is still no direct evidence to support it. Instead, scientists continue to focus on the possibility that 3I Atlas is a natural object that is simply very unusual. After all, it is an interstellar object, and as we've seen with previous discoveries like Oumuamua and 2I Borisov, objects from other star systems can behave in ways that don't always align with our expectations. One of the key pieces of evidence supporting the natural origin of 3I Atlas is its composition. The object has shown signs of being made up of materials that are typical of comets, such as ice, dust, and rock. While its chemical activity is unusual, it is still consistent with what we would expect from a comet that has spent billions of years traveling through interstellar space. The fact that it has been so hardened by cosmic radiation that its ices are not sublimating until it gets closer to the sun is just one example of how interstellar objects can behave differently from those in our own solar system. The unusual chemical composition, with traces of carbon dioxide and a lack of water vapor, also suggests that it came from a star system with conditions vastly different from our own. The discovery of carbon dioxide around 3I Atlas adds another layer of complexity to its mystery.